So in example 2, we've been asked to express this complex number in modulus argument form, and then to solve this equation, leaving our solutions in exponential form, and to plot them on an Argand diagram. So perhaps you want to try part A. You can pause the video and come back when you're ready. So welcome back if you had a go. So we have this Argand diagram, and we have 18 root 3 as the real part, and negative 18i on the imaginary part. So the complex number will be about here. And we need to find the argument theta. So theta will be the arctan of the opposite over the adjacent 18 root 3. So theta works out as negative pi over 6. And then the radius will be the square root of 18 root 3 squared plus the 18 squared. And this is 36. So in modulus argument form, 18 root 3 minus 18i we can write as 36 times the cosine of the argument plus I sine of negative pi over 6. Okay? And then for part B, to solve this equation in exponential form, well, we know the radius of this is the 36. And theta will be negative pi over 6 or negative pi over 6 plus 2 pi or 4 pi. So we'll say that z to the 4 is equal to the radius multiplied by e to the I, and then the argument is negative pi over 6 plus 2k pi. And then we'll take the fourth root of both sides, so z will be the square root of 6, e to the I. We'll divide each of these by 4, so negative pi over 24 plus 2k pi over 4, or k pi over 2. And this is using De Moivre's theorem. And then I'm going to simplify this with a common denominator. So z will equal root 6e to the power of 12k pi minus pi over 24 times I. And we can work out the nth roots if we let k equal 0. Then our first solution will be root 6e. This term will go, and we'll get negative pi over 24i. If we let k equal 1, our second solution will get the 12 pi take away pi, so 11 pi over 24i. And then when k equals 2, our third solution will be root 6e. This term will become 24, take away the 1 over 24 pi I. And if we let k equals 3, then this becomes 36 pi, take away 1, so 35 pi, and that goes beyond our range. So now we need to let k equal negative 1. So Z4 will be the same radius. We'll get negative 12 pi, take away another 1, so negative 13 pi over 24i. We have our radius of root 6. And for Z1, we've got negative pi over 24. So that will go about here. For Z2, 11 pi over 24. For Z3, 23 pi over 24. And for Z4, negative 13 pi over 24. And we can see this is right because they're separated by 90 degrees or 2 pi over 4, which is omega pi over 2. Okay?